Hello. As we progress from childhood to adulthood, we continuously acquire more complex knowledge. But how does the brain physically encode this lifelong learning? Two competing paradigms exist. One is the expanding architecture paradigm, and the other is the modifying weights paradigm. Which one is more likely? The first paradigm suggests that learning takes place within a fixed neural architecture. As new vocabulary and complex ideas are introduced, the network simply fine-tunes how these nodes interact. In this model, the network does not grow in size. Instead, it learns by continuously modifying the strength or weights of the connections between existing neurons. Alternatively, a second paradigm argues for structural expansion. The brain would physically need to expand its topology to accommodate the new data. This happens by network dynamically adding new neurons, layers, and entirely new connections to scale up its capacity to learn more complex concepts. This brings us to a critical question. Which of these two paradigms actually reflects how we learn? Research demonstrates that with a known learning mechanism, processing larger datasets increases the network's accuracy. Yet, the maximum allowable network dilution remains entirely unaffected by the size of the dataset. This implies that performance improves through better cooperation of existing components. On the other hand, biologically, the number of neurons in the brain remains relatively constant, and there is no evidence for a biological mechanism that reconfigures neural topology on a large scale. Therefore, the evidence strongly favors learning by modifying weights. We invite you to learn more by visiting our website.